Hello once again. I'm Projectile. This time I'm going to share with you some strategies used to solve problems of physics. Many students have trouble when attempting problems on their own. One of the solutions to this problem is to do more practice. Some strategies to be used. We have to ask ourselves, what do we know? What are we looking for? Which formula are going to use? Does your answer has a physical meaning in magnitude and unity? We are going to do some practice. The problem number one, an object starts to move from rest with a constant acceleration of 8 meters per second squared along a straight line trajectory. Find the speed at the end of 5 seconds. Find the average speed for the 5-second interval. So as an object starts to move from rest, the initial speed is 0 meters per second. Also, we are given the acceleration of 8 meters per second squared. And the time used is 5 seconds. The unknown, we are asked to find the speed and the average speed. The formula, we are going to apply the kinematics equations. So for the speed, we are going to use the first equation of motion. V is equal to the acceleration times t plus initial speed. And the average speed is equivalent to the instantaneous speed plus initial speed divided by 2. The numerical application, the speed is equal to 8 meters per second squared times 5 seconds plus 0, which is equivalent to 40 meters per second. For the average speed, we have the 40 meters per second plus 0 meters per second divided by 2, which is equivalent to 20 meters per second. You see that it is simple. So just you have to do more practice to be familiar with this problem of physics. The second problem, the speed v of a runner in a rectilinear motion varies as a function of time according to the following curve. Here we have the velocity time graph. 1. Precise the nature of motion and determine the acceleration of the runner for each phase. So for the phase 1, the runner is moving from 0 meters per second to 8 meters per second using 2 seconds. So the nature of motion here, we are going to look at the final speed and the initial speed. If the final speed is greater than the initial speed, it means that the acceleration will be positive and we have the uniformly accelerated rectilinear motion. If the speed is constant, like the second phase, the initial speed is equal to the final speed, it is 8 meters per second. Here we have no acceleration. For the third speed, there is a decrease of speed. The speed is decreasing from 8 up to 4, which means that the acceleration is negative, because 4 minus 8 is a minus 4. And we have uniformly decelerated rectilinear motion. For the last phase, it is similar to the second phase. The velocity is constant. The speed is not changing. For the second phase, the speed is 8, but for the fourth case, the speed is 4. Here, we have uniform rectilinear motion because we have no acceleration. For the second question, determine the total distance traveled during all 16 seconds. To find the distance, we are going to calculate the area of the graph. Here we have the triangle, and remember the area of a triangle is a half of the base multiplied by height. And for the second phase, we have a rectangle. And remember the area of a rectangle is the width times length. For the third phase, we have the trapezium. And remember the area of a trapezium is a half of big base, this one, plus small base multiplied by the height. For this case, the height is this, 12 minus 10. Then, yeah, that's it. Okay, for the last phase, we have also a rectangle. And the area of rectangle, it is base or the width, 16 minus 12, multiplied by the length, which is 4 minus 0. Okay? Whereas for the acceleration, you are going to calculate the slope. Here, the slope will be the vertical change divided by horizontal change. Here we have no slope, the phase 2, because we have the horizontal straight line, and the last phase, we have no slope, which means we have no acceleration. For the phase 3, we have negative acceleration, and phase 1, we have positive acceleration. Okay? So as I said before, the acceleration is represented by the slope of the velocity time graph. For phase 1, the final speed is greater than the initial speed. We will have uniformly accelerated rectilinear motion. And for acceleration, we are going to calculate the slope. Slope is the vertical change divided by horizontal change. Vertical change is the change of v divided by the change of t. And for final speed is 8, initial speed is 0. So 8, we will have 8 minus 0 divided by 2 minus 0. It is 4 meters per second squared. For the second phase, the final speed is equal to the initial speed, which means we have the uniform rectilinear motion. And the slope is calculated as the vertical change divided by horizontal change. Vertical change is the v, change of v, and the horizontal change is the change of time. Here we have 8 minus 8 divided by 10 minus 2, which is 0 meters per second squared. For the phase number 3, since the final speed is less than the initial speed, we have the uniformly decelerated rectilinear motion. And the slope will be 4 minus 8 divided by 12 minus 10, which is minus 2 meters per second squared. For the last phase, phase number 4, the final speed is equal to the initial speed, and we have uniform rectilinear motion like the phase 2. The acceleration will be calculated as 4 minus 4 divided by 16 minus 12, which is 0 meters per second squared. For the distance is represented by the area under the velocity time graph. And for the phase 1, we have a triangle where the base is 2 and the height is 8. So D1 is 2 multiplied by 8 divided by 2. For phase 2, we have the width, which is 8, and the length is 8. For phase 3, big base is 8, small base is 4, the height is 2, and we have this. For the last one, we have the width, which is 4, and the length is 4. Finally, the total distance will be the sum. It is 8 plus 64 plus 12 plus 16. It means D1 plus D2 plus D3 plus D4, which is 100 meter. Okay, the third problem, a 2 kilogram mass projectile is shot upward from the Earth with an initial velocity of 20 meter per second. At what height is when its velocity is 10 meter per second? Calculate the time of flight of the projectile. So here we have the vertical motion where the object is thrown upward. Okay, so we are given the initial velocity, which is 20 meter per second. The final speed is 10 meter per second. The acceleration due to gravity, that is given not explicitly, but as you know, is 10 meter per second squared. Unknown, we are asked to find the height and the time of flight. The formula, we are going always to use the kinematics equation. The h is equal to v final speed squared minus initial speed squared divided by minus 2g. Remember, for the upward motion, the acceleration g is negative. That's why here we have minus 2g. For the time of flight, we have the twice of Tmax. Tmax is the time used by the projectile to reach the highest point. So the time of flight is equal to the 2 times Tmax, because the time to go up is equal to time to go down, and the time of flight is the total time. Time up plus T down, where Tmax is equal to initial velocity divided by g. So numerical application, the height is equal to 20 squared minus 10 squared divided by 2 times 10, which is 15 meter. The time of flight is equal to 2 times 20 over 10. 20 over 10, it is Tmax, and the time of flight is to be times 2, which is 4 seconds. The fourth problem, from the roof of a building of 30 meter height, a stone is vertically thrown upward with an initial speed of 10 meter per second in the vertical frame downward oriented. Determine the speed of the stone when it reaches the ground. Determine the total duration of the free falling motion. So here also we have the upward motion, but the objects start moving from a certain vertical distance, which is the height of a building of 30 meter, which is y0. We have this kind of graph. We have a building of the height y0. From the building, the object starts moving with the speed of 10 meter per second, that is initial speed, and up to its highest point. At the highest point, the final speed is equal to 0. And then when the speed comes 0, the projectile turns back to the ground. So the distance y0 plus y max is y. That is the total distance moved by the projectile from the highest point to the ground. Unknown, we are asked to find the speed of the projectile on the ground, the time, the total time used by the projectile from the building up to the ground. The formula to be used, the speed to be square root of 2gy. The speed to reach the ground, it will depend on the total distance moved by the projectile, y. And the time used by the projectile, it is T max, time from the building to the highest point, plus time from the highest point to the ground. That is the total time used by the projectile, where T max is depend on the initial speed. T max is equal to U divided by G. And then T down, time used by the projectile from the highest point to the ground, it depends on the moved distance y. It is square root of 2y divided by G. The numerical application, T max is equal to initial velocity, which is 10 divided by 10. It is 1 second. So y max, it will be equivalent to u squared divided by 2g, which is 5 meters. And then the total distance moved by the projectile, y, is equal to y0, the height of building, plus y max, which is 35 meters. The t down, the time from the highest point to the ground, it is square root of 2 multiplied by distance y divided by 10. It is 2.64 seconds. Thus, the velocity or the speed used by the projectile to reach the ground, it is square root of 2 times 10 times 35. Remember, it is 2gy. G is 10 and the y is 35. That is 26.4 meters per second. And the time, the total time used by the projectile, it is equivalent to 1 second. The time used by the projectile from the building to the highest point, plus the t down 2.64, which is 3.64 seconds. Finally, we have this graph, the building of 30 meters, the y max 5 meters, and the total distance, which is 35 meters. The problem number 5, in a vertical frame OZ, downward oriented, a body has a free falling motion without an initial speed and travels 245 meters during the last second of its motion. Determine the time duration of the falling motion for the body to reach the ground, the falling height, and the speed of the body when it reaches the ground. So here also we have the vertical motion where the object is moving downward. And we are given this graph where the projectile starts moving from initial velocity equal to 0. It is moving downward. Here we have 2 important positions. The last position is Z, the function of t, and the position Z, t minus 1. Where comes 1? It is 1 second. This is the position of the projectile before 1 second to reach the ground. And the interval or the distance between the two, it is 245 meters, which is the distance moved by the projectile during the last second. The last second, the distance moved in 1 second from zt minus 1 to zt. So the formula to be used, z, we are going to use the kinematics equation, which is the equation for distance. Z in function of t, it is equal to 1 over 2 gt squared. So z in function of t minus 1, we are going to replace t minus 1 into this formula. It will be 1 over 2 g t minus 1 power 2, which is 1 over 2 acceleration due to gravity multiplied by time squared minus 2t plus 1. So 245, it is the distance between the two positions. Position z in function of t and position z t minus 1. So 245 is the difference between the two. Z minus z in function of t minus 1. And remember, z in function of t is 1 over 2 gt squared, and the z in function of t minus 1 t is this one. Finally, we have 245 meters is equivalent to 10 times time minus 5 by replacing the value of g, which is 10 meters per second squared. So finally, we are going to have the time t, the total time used by the projectile from the initial point to the end point, which is 245 plus 5 divided by 10 from this equation, which is 25 seconds. And B, we are asked to find the height. The height is equivalent, the total height from the initial to the end is equivalent to the position z in function of t. So replacing the value of time into this equation, we have 1 over 2 times 10 times 25 squared, which is 3,125 meters. So the speed used by the projectile to reach the ground will be square root of 2gh. It will depend on the height moved by the projectile. So as the height is 3,125, we are going to have the speed of 250 meters per second. So you see that it is simple. Just you have to do more practice to be familiar with these kind of problems of physics. Thank you for watching. Remember to subscribe, like, and share for these for the new tutorials to reach you on time. Okay, and this will help you to get the tutorials automatically. Thank you very much. Have the